All right, join me for the Math on the Spot video. Make sure you have scratch paper so you can follow along before you get going. All right, here we go.
You know, there's numbers all around us, and a lot of those numbers actually say something about age. And in fact, when you're measuring age, you can actually use age as a very powerful way of understanding large groups of people. In fact, this reminds me of a great riddle that actually was led by Corey. Let's take a look and have some fun thinking about Corey's question and how we might, in fact, answer it. Okay, Corey collected data on the ages of the parents of his classmates. Let's make a data display and use it to find the percent of parents at least 30 years old, but under 50 years old. Now, there are lots of ways we can actually make a display, right? We saw a few of them actually earlier. There's the dot plot. That shows the frequency of data. There's the histogram. That shows the frequency of data in intervals. And so which one should we use? Well, since we have lots and lots of ages, in fact, here are all the ages, I think actually thinking about things in intervals makes sense. In fact, we actually are given the intervals. We can think about the intervals that are under 30, the parents that have ages under 30 years old, the parents that have ages 50 years old or older, and then the ones that are in between. So we have like 3 intervals. So in fact, we can actually analyze it that way. And how might we do that? Well, the first thing I would do is here are all the ages just written down as Corey collected them. It might actually be easier for us to actually order the data from smallest to largest. And if we do that, this is what we would see. This is the exact same collection of numbers, but written in order. Let me just show you a couple of them really fast. So here I see 27. Let's find the 27. There's 27. Then I see 29. Where's 29 right there? Then I see 32, there's 32, 35, there's 35, 36, there's 36, oh, 37, there's 37, 38, there's 38, and so forth, all the way out until we get to 52, which is right here. Okay, now let's actually produce 3 different intervals that we're interested in. So here they are. One interval is less than 30 years old. Then the interval that we really want to study, which is the interval where the age is at least 30 years old, but less than 50 years old. And then finally, more than 50 years old, or in fact, 50 or more. Okay, so here we go. Let's see. Well, it's actually pretty easy to do. Because less than 30, just start at the beginning, and since they're written in order, we could have done this in the original ordering, the way that Corey collected it. But now that it's numerically listed, we can say less than 30. Well, that's going to be, where's less than 30? That's less than 30, but that's over 30. So in fact, less than 30 is right this group right here. And now at least 30, but less than 50. Well, that's all the way up. Now that's not less than 50, that is 50, so 49 is the largest number less than 50. So I'm going to circle all those. You see how nicely you can kind of quickly just lasso them in? And then 50 or more. So more than 50 years old or equal to 50. I'll write that in there, right? Or equal to 50. Or 50. There we go. So that will save me 10 times, trust me. Okay, so now what do we see for the answer? Well, how many are less than 30? 1, 2. So I just count how many I see. So the frequency is the count I see, 2. How many do I see here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I see 12 here. Now let me just tell you something, because you're my friend. When you're dealing with data that's big like this, it is so easy to get distracted, to look away, forget where you are, and all of a sudden this becomes like 10 instead of 12. Be really careful and take your time in whether you're copying out the numbers in order or whether you're counting how many there are. Make sure that, in fact, you're presenting the correct number of them. Wouldn't it be sad? You understand this math so well, and yet you make a silly little mistake and get the wrong answer. So really, be careful. In the last group, it's easy to see there's just 2. Okay, terrific. Well, so now the question is, what's the total number of data points that we have? Well, all we have to do is add them all up, and we see 2 plus 12 plus 2, which is going to be 16. So we have 16 ages total. And so what we want to do is we want to, first of all, we can now plot this stuff. And we're going to use a histogram, since remember a histogram shows the frequency of data in intervals. So I've got the interval less than 30, the interval that is at least 30. I want to say at least 30, at least 30, at least 30. So at least 30. At least. At least. At least. At least 30, but less than 50, and then greater than 50 or 50. So you got to be careful when you read these things. Okay, great. So now, how would you actually create the histogram? Well, you have the frequencies, and that tells you the heights. So here we go. Remember, there's no gaps. We're creating now a bar chart, a bar graph. And so the first one, less than 30, we have 2 people. So that's 2 right here. So what I'm going to do is I'm going to just color this in. Color this in like this. Okay, so I'm going to do this kind of fast. In fact, you know what? This is going to be like one of those cooking shows. There it is. It's done. Great. Now, how about at least 30, but less than 50? Well, that category has a frequency of 12, so we have to go all the way up to 12. So that's going to be a big bar. That's a big, big bar. That's a big old bar. That is a big bar. Big bar. Okay. And then finally, 50 years or more, that's going to be 2 again. So we have that same height of 2 as we had before. And to really emphasize that we are having a bar, a histogram, you might want to kind of highlight the different bars. I kind of like to do this, just to really make it clear. It kind of celebrates it a little bit and lets you see the different bars. I kind of like doing this this way. Yeah, I kind of like that. That looks good. So there is the histogram. There's the histogram. Now, so we created a way of visualizing the data, and then we want to find the percent of parents at least 30, but no older than 50, and so that's this middle range. So that's just the relative frequency, and so the relative frequency we could actually find very easily. All you've got to do is take the total number that is in that particular part and look at the ratio of the part to the whole. So that's 12 sixteenths, which can be simplified to 3/4, and that can be written as a percentage by writing it as a decimal, which is going to be 75 hundredths, which equals 75%. And so 75% in fact is the answer, meaning that 75% of the parents have an age at least 30 years old, but less than 50 years old. And we were able to find that by taking the raw data that Corey collected, writing that data in numerical order, figuring out 3 categories to consider, the category we want, and then the category of ages below that, and then the category of ages above that, clustering and clumping the data into those 3 groups, seeing how many we had in each group, the frequency, then producing a way to display that data using, in this case, a histogram. We did that correctly, and then we actually could find the relative frequency by comparing that part to the whole and writing it as a percent. Wow! It's absolutely fantastic that we could take things as basic as ages and all of a sudden study interesting, intricate facts about that collection. So Corey went out and did some really great work, and so did we. So we should feel great about our understanding of statistics. Have fun thinking about the statistics all around you, and I'll see you soon.
All right, thanks for watching. I'll see you on the next one.